Okay, so this is another video for OrgoChem Simplify. And in this video, I wanted to quickly go over the most basic concepts that you need to know for all of Orgo, right? And so this is not going to be a comprehensive list, but it'll just give you an idea of, the small amount of concepts that you need to know for all of Orgo. So this is just going to be a list. It's not going to be in depth. So, make sure you understand these concepts before you watch my videos, because my videos will mostly be, walking through long mechanisms or long problems. Okay? So, first thing to know is chirality. Okay, so chirality. Next thing you want to know is NMR, the basics of NMR. So basically, how does that work, right? So under NMR you have splitting and chemical shift. Okay. You have IR, infrared spectroscopy, and that just has to do with bond vibrations. Okay. So those are the two most basic things you'll cover. I guess mass spec, right? So that's basically just measuring the mass of each molecule. So units of unsaturation. So how many double bonds there are in a molecule. Next thing you want to know, SN1, SN2, E1, E2. So under that goes nucleophilicity, electrophilicity, okay, acid-base chemistry. Acid-base chemistry, so acidity, basicity, next thing you want to know is electron donating groups. So like, you want to know hyperconjugation, and electron withdrawing groups. Naming rules. You want to know how to draw resonance structures. Molecular orbital theory. Molecular orbital. And the last thing I'll add is basically carbonyl reactivity, and that's the C double bond O. You need to know how that reacts. And the last thing is basically metallic compounds. And that will cover most of the things you need to know in Orgo to actually answer any problem. Right? So, as you can tell, I can limit this to one whiteboard. So, chirality, NMR, IR, MS, these are lab techniques, right? You will need to know naming rules, right? That's going to be in the beginning. Units of unsaturation, also be in Orgo 1. SN1, SN2, E1 and E2, nucleophilicity, electrophilicity. This is basically a majority of Orgo. Yeah, and acid-base chemistry. Most reactions will be a combination of these two. So you need to know electron donating, electron withdrawing. So that's going to contribute to acidity or nucleophilicity. They have an interplay with each other. You need to know how to draw resonance structures, molecular orbital theory, to understand the reactions at a molecular level. Right? The reactivity of a carbonyl group is, a large part of Orgo 2. Metallic compounds. Oh, one last thing, and this is the very last thing. Leaving groups. And more importantly, leaving group stability. So that's going to have a large effect on whether reaction will go. So that's basically it. Concepts of Orgo boiled down into a single whiteboard. So hopefully that helped you in terms of simplifying Orgo and helping you see that there's not that much that you need to learn in Orgo. The rest is just reasoning through it. Okay? So hopefully that took the edge off Orgo, made it a little simpler, and thanks for watching.